Hello everyone, this is Stas and welcome to my new TouchDesigner tutorial, and today we want to talk about vector fields. And I already made a tutorial about vector fields almost a year ago, and that video was very popular. Maybe it's because the vector fields is such an iconic example of generative art, maybe by some other reasons. So I want to continue with that, and in previous video about it, I mostly explained how it works, why it works, and basic details about vector fields. So today I'm gonna show you mostly different tricks you could do with it. And also in the end, I'll show you how to apply it not to the video but to still images, because many of you probably know the vector fields from still images, something like this one. And usually TouchDesigner is used to generate videos, but you can use it, of course, to generate still images as well. So, how it will be organized? First of all, if you very new to vector fields, or it's also called flow fields, probably you'll need to watch the previous video. But if you already knew what vector fields, maybe from my video, maybe from somewhere else, then you don't need to watch anything, because I'm going to explain you how my code is worked and give you a starting point. So this component will be our starting point, and I'll share it with everyone, and you could find the link in the description. So if you wanna follow me in this tutorial, please download the starting point, copy paste it, and we will work here and call it recording. I will share this one as well, and this one would be our final points, and the components here is our steps. This our steps, and I'll share it with my Patreon supporters on patreon.com/xstas. So if you want to support me, you could download all of them there, but we will do most of this here and right now. Here it's just better to do it step by step with like a separate topics, while right now we will do everything in once. Okay, first of all, let me dive into the starting point, and let me explain you a little bit of vector fields or flow fields if you haven't know much or forgot about them. So vector fields is just a bunch of vectors, in this case a two-dimensional, because it's much easier to code. Two-dimensional vectors that affects how particle moves. So they gives the velocity up for a particle, like a direction and a speed. So if I put the particles, they start moving where this vector fields show, where vector fields goes. Okay, how it's made, how it's organized in the code here. The code is very simple. It's very similar to what we did in the first part, but even simpler, because I wanted to start with something super simple and make it more and more complicated with every step. So the code, and it's very short GLSL code. If you don't know about GLSL anything, probably you still could understand what's going on. Okay, here is our GLSL component, and the code, and it has three inputs. The inputs 0, 1 and 2. From input 0, it's our current position and age. We store the two-dimensional position in red and green channel and age in alpha channel. And it's a feedback system. So after we do all our calculation, we feedback it to this top node. The third input is our velocity, our vector field, and it's just a simple noise. It's important to make it 32 or at least 16-bit float, and it's not necessary. I just did it to make it more easy to understand. I deleted the blue channel because we only need red and green. So in a noise I create the non-monochrome noise, so it's RGB noise, and now we have RG noise. And I put the math to increase or decrease our vectors. Okay, it's our third input, and the second input is a default position and age. Here in the parameters we have parameter called aging with two numbers. So let's look into the code. We read our position from the input 0. We read our velocity from the third input, and now we read our age from alpha channel, and on every step we decrease age for this amount. And when the age becomes this one, so 0 in our case, then we use default position and default age, so everything starts again. And after that we add to the position our velocity, and I multiply velocity with two numbers because it's easier for me, because it's feedback system, and all feedback system needs super small values. So here I have a small value, it's 1 divided by our FPS, and second parameter, if I want to increase velocity or decrease velocity, I could do it easily here, because it's really hard to increase or decrease such a small number. Okay, now let me show you how it better turn on this, and I turn off vector fields. So I press 1, I'm resetting everything, and it flows, and age decreases, maybe if I speed it up a little bit, it would be, yeah, now it's a little bit clumsy, but more easy to understand. So every step age is decrease, and when it decreases to the 0, all particles returns to the initial position, to default position. And because the age is constant here, it all ages in the same rate. So it all burn and die in the same frame. And so if I increase the velocity, it moves faster. If I decrease the velocity, it moves, if I decrease, it moves slower. And I could increase age, or I could turn off aging, and these particles wouldn't age at all. And probably that's all what you need to know about how it's all organized. And here you could set the number of particles. Maybe in this case you need to scale it a little bit smaller, and not so much small. Yeah, here, and maybe increase the velocity, maybe 0.5. So probably you got it. And here is our standard rendering setup instance. Inside the geo I have a rectangle, and as a texture is just a circle with constant. If you're interested about, it wouldn't work well. Let me decrease it again. And increase this. If you're interested about these arrows, you could go inside this flow field rendering component. It's made with line material. It's not our topic, so I'm not going to explain how it's done, but if you're interested in this technique, you could try to figure out it yourself. So that's it for the beginning, and let's start to modify it and make it more interesting. First of all, let me move it. It's also color coded, so I hope it's more easy to understand. Here is our rendering, here is our calculating the parameters, and everything to create vector fields is over here. Okay, and let me turn it on, turn it off, and make it a little bit. Okay, I'm okay with that. First of all, what I don't like here is all particles was born and die in the same moment. So maybe instead of constant age, we could use the noise age. So let's create a noise. Let's copy the resolution. It goes from this copy parameter, paste expressions, pixel format. Actually, it doesn't matter, but let's make 16-bit float. So over here, our age was 1. Let's make our age, the medium age would be, let's say, 0.9, and the amplitude would be 0.3. And it should work now differently, so particles should burn and die in different moments. And as you could see, some new particles was born, some die, so it's not like it was before. It's not die in the same moment, like here. It's all, maybe it would be easier again. It's burn, it's die, it's burn again, it's die, it's burn again, and if I switch, it's more chaotic in different time. Alright, that's the first thing. Next is position. It's all in the same position. It's also very boring. So let's add a noise here. Let's add a noise, and in output, input plus noise. We don't want monochrome noise. The pixel format should be float. Everything is fine. And offset is 0, and amplitude, let's make it very small. So as you could see, now particle born in different places. Maybe it should be even smaller. Yeah, like this. Very nice to me. Maybe a little bit more. And you could experiment with different noises, so particle burn in a little bit, not in regular grid, but something more distributed. Okay, let me check what I want to show you next. Position. Okay, it's just a reminder for myself what I want to show you. Okay, right now our particle burn in grid because it's just a UV map, so it was burned in the grid. But we could use something different. We could use, for example, here in the palette we have point clouds and we have point generator. We could use this and generate, for example, point on the cube surface, and let's make a transform because we will need to rotate it or do something else. And we want the same number of points, so let's just for the number of points use parameter x multiplied by parameter y. Okay, so it should have same number of points. Let me make it null. Let me go to the null. Yeah, the same number of points. And if I use it instead, now the particle born in the grid, but it's a super big cube. We need to, first of all, let's make it smaller. Well, it's very small. And also our particles right now is go from the 0 to the 1. And the center of the cube is 0, 0. So we need to move it like 0.5, 0.5. Yeah. And let's also rotate it randomly. So we could create our particles. Sorry for my pronunciation, I usually pronounce born and burn in a kind of similar. Sorry. So we create our particles in the cube and they fly away from it. Or another approach, you could use something like soap, like make it torus. Let's also move it a little bit and let's make it soap to chop and then to top. Alright, and we need to RGB, and again we need same amount of particles just to make it easier. We could delete it, but it's much easier right now just to reference the same number. Okay, and yeah, fit the square. So let's move it again to the center and let's see what's going on right now. Oops, again too big. So right now we could use the particle starting from the torus. Okay, what else? Let me go back to our initial version. Also, sometimes you don't want particles to fly away. Right now in the camera I use orthographic camera because it's two-dimensional and I prefer orthographic view for two-dimensional visualization, but you could use the perspective, it also works. Okay, orthographic, and I make it the scale a little bit bigger than our 1 by 1 square to see the borders. So let's make a borders. It's a limit top, and we could adjust what particles should do when they reach these limits. Let's make it, for example, loop. It's my favorite. From 0 to 1, and when particles moves to the right side, it appears from the left. And if it goes to the top, it appears from the bottom. You could also use, for example, clamp or zigzag. Zigzag usually don't work because here's our field, and even particles start to bounce from this border. The vector field is same, so it always pushes it back to this border. So it just bounce until the vector field moves. But here we could see a little bit of problem on the borders, especially if you use clump. Our particles could clump together, could clutter, and so all our particles in the same position, and it's not very nice looking. So we could do something about that. And what we could do, we could add a noise here as well. It should be before feedback, so we need to paste it here. Let's paste a little bit of noise here, just a super tiny bit, maybe something like this. Not so much, maybe a little bit bigger. Yeah, probably even, oh, it shouldn't be monochrome. Okay, right now it's good. Yeah, and we need to make it smaller. So we still have a cluster of particles, but it's not very packed in the same position. It's a little bit dispersed because of noise. And also, nevertheless, on the border, it's in the same position because the vector fields pushes toward the border. And the borders is usually, when it's not a loop, it's usually looks a little bit ugly. So what I prefer to do is to hide them. So I prefer to set my camera a little bit smaller, so the particles flow away and you don't see the borders at all. Okay, that's it. Next, what's next not so nice about this one? Let me make it a little bit less visible. I don't know how it would be visible on YouTube. I hope you still see a little bit of arrows, but not so much. Okay, next, let's reorder the age. Here is our age. As you could see from the code, or here from the code, the age is stored in the alpha channel of position age texture. And here on the output we store it in the same alpha channel. So if we, from the input, if we took the alpha, yeah, alpha 1. Let me see what's going on now. Okay. Sorry, I don't understand what's going on right now. It should decrease, but it's not decreasing. Why it's not decreasing? It's alpha channel. Let me check how it works here. Age, alpha. Reorder. Everything is alpha. Why it's working here and not working here? Mysterious. Something strange going on. So it decrease. Okay, let me pause for a little bit and I'll be back when I figure out what's going on here. And I'm back. So here's the deal. Here's our noise. This is our noise, and by default for the noise stop the output for alpha set to 1. So it makes the alpha channel, so our age 1 always, and we need to set it to the back to the input. And now we have age here, and as you could see the age of a pixel decrease like it should do. Also I found that I connect the limit outside of feedback loop, and probably we would like to see it inside, because the limit affects the particle position and we need to feed it back to the particle position. Sometimes in some rare cases maybe you want to limit it outside of feedback loop, but usually it should be inside. Okay, so it was a nice pause, nice bug, and don't do this. Okay, here we have our edge, and I want to use this edge for a scale. So if I connect the edge to the scale, I hope as particles go smaller and smaller, as particle edge, it goes smaller and smaller, because our particles burn with the edge about 1 or a little bit less, and die at edge of 0. So the scale goes from almost 1, depending on this noise, to the 0. Okay, let's make it move a little bit smaller so it wouldn't distract you very much. But here is a little bit of issue, because our particle burn with edge around 0, it just appears very big from nowhere. It's just some big particles appears from nowhere. And what if I want to make it a little bit differently? What if I want particles burn small as a child, and then grow, and then grow back, so decreasing the size? So we could do it with the ramp. We could use the ramp, and I want our edge work something like this. So a particle born with small one, maybe it would be much easier to understand here. So until the age of 0.2, so 20% of a life, it goes from 0 to 1, then 60% of a life it's spent on the size of 1, and then decrease again to the 0. Or maybe you want to organize it somewhat differently. And we could use the lookup top. Look up here. And now if I connect it here, it should work. Would it work? Let me increase a little bit of edging. So as you could see the part, and let me make a limit to the loop. And it's not working. Why it's not working? It would work if I set it like here. When particle is born, it goes from 0 to 1, and then back to 0, and then reappear again. Why it's not reappearing again? Okay. And again and again and again. Okay, but why it's not working if I use the noise edge? It's not working because our initial edge, it's not always 0. Sometimes it's not always 1. Sometimes our edge, our default edge in the particle, when particle created, is, for example, here 0.31836. So, and 0.3, it's somewhere over here. So it's not, so that's why it's created on a full scale. So what could we do about that? We could divide our default age to our current age. We could use the math and divide one by another. Oh, sorry, we couldn't divide by math, we could divide by composite. We could divide by composite, right? And let's set it to nearest pixel, divide. And now probably it will work. As you could see, if I reset, it starts and goes and goes and everything works fine. And the funny thing that I'm using the composite divide because I just suddenly remembered that we could divide with tops, but here if you go on my Patreon, I created the special GLSL just for dividing because I forgot about divide in composite top. So you could divide with GLSL as well, and probably so it's almost, well, 0.1, 0.2 milliseconds. And let me check here our divide. Well, it's even less. Well, it's not less. Sometimes it's less, sometimes it's not. So it's about the same effectiveness. So you could use GLSL or you could use divide. All right. Now we have interesting scale effect on the age. And of course, by manipulating this ramp, you could do different kind of stuff. For example, particles could pulsate over the life and go smaller and bigger and smaller again, or do something else. Okay, this is our age trick. Now our scale is based on aging, and you could also use the same approach if you want to make... Oh, let me do it right now. Let me use some kind of another ramp, and let's make it in contrast colors from the orangey to bluish, something more bright. And I could do it for the colors as well. I'll look up, ba-bam, Alt plus N, color, and we could instance the color as well. Okay, so our particles was born in one color, and it goes over the edge, it goes to the more bluish and to orange, and so on and so on and so on. Well, it's, yeah, maybe it needs a little bit more bright, but anyway, I could adjust it a lot and do it and spend a lot of time to adjust it very nicely. But I don't want to spend your time on this, just aesthetic adjustments. You could do it yourself. And let's move on. And let me check what I want to show you in the next. So I talk to you about different tricks about position. Okay, it's done. Edge trick is done. And now it's time to finally talk about forces, because our flow fields, our vector fields it's mostly about these vectors. So let's do something with these vectors, and let me turn off the colors so it wouldn't distract you, and make it all blue again. And actually I turn off rendering and leave only the vector fields, because now we will concentrate on our vector field. Maybe this one. All right. So right now vector fields is very simple. It's just a noise. What could you do? First of all, you could combine several vector fields. Let's, for example, add a gravity to our particles. Let's add a constant top. Let me call it gravity. It should be, let's say, 32-bit float and the same resolution. Copy, paste expressions. So the gravity, it means that the green channel should be a little bit negative. And let's just add these two vector fields. And now, as you could see, we have our gravity. If I increase it to 0.5, suddenly we have much more gravity. And if you want to see effect on the particles, it looks like snow. You could also add a wind, for example. And in general, you could add the different vector fields or different noises or different whatever to make it look more differently. And a similar approach, but a little bit different, is to use the masks. And let me, for example, create a simple mask. Let's use, for example, a circle and the same resolution. And let's make it circle smaller. All right. And it would be our mask, and we need, here is our first. Let me turn off, oops. Let me turn off my gravity. And now I will create the second vector field. And one trick you could do is to use math. And you could multiply this vector field by, for example, 10. So it would be the same directions, but 10 times faster. And now let's make the math top. Pum, pum, pum. And I want to switch the inputs. So now the particles on the center should move much faster than the particle of the corners, but it should be the same direction. Let me check it. And yes, it moves very fast on the center and much slower. Maybe it's too fast. So maybe 7. And I like this kind of effect, so the same positions, the same directions, but a little bit more faster movement on some regions. Yeah, maybe I'll decrease the particle. Okay. What if you want to add interactivity to your particles? Let's make it with a mouse, but of course you could use the Kinect, or you could use whatever you want. Let me make another circle, even smaller this time. And this time I also want it to be soft. I explain it a little bit later. And for our position, we need to center it over here, over here. It moves from -1 to 1. It moves, okay, we need to set it to normalized. and we need to divide it by 0.5. I mean multiply by 0.5 or divide by 2. Okay, here's our interactivity, and I explained it in more details in the first part of the tutorial, but you could either create GLSL top to construct the gradient force, to construct the force depending on the gradient. So and the same trick would do the slope. Sometimes slope a little bit buggy, but usually in 99% of the cases it works fine. If you want to know more details about that, check the first part of the tutorial. Okay, 0 point is 0. For the red we want horizontal luminance, and for the green we want vertical luminance. And blue is 0, and the strength may be 3. So now let me show it to you. Let me show it to you just on the mouse. As you could see, and here is our problem, because it's 8-bit fixed, and of course it should be float, like 16 on 32-bit float. So now, depending on the gradient, so when pixels goes from the brighter to less bright, it's goes to one direction, and if it darkens, it goes to the other direction. And actually I prefer it to do the opposite. So now it goes outwards. And now I could kind of push the particles with my mouse. Maybe it's just very tiny, so if I increase the strength, now it's really pushing the particles away from the mouse. Maybe it's a little bit big. 0.1. Alright. And by the way, you could use here the strength, or you could use the math and multiply it even more, and now you could push the particles. And of course you could combine it. For example, here is our noise. I add noise with the mouse, and well, yeah, in this case I should increase it here. So we have a noisy flow fields, but I also can interact with my mouse. Another approach, which okay, let me show it to you. Here in the palette, in the tools, we have optical flow component, and let me put it here. And what's -20, -20, and let me again use only this, only mouse, and let me turn off display and everything. So now the difference between the slope and the optical flow, it's compared the previous frame and the next frame. So when my mouse doesn't move, there is no force. If my mouse start moving, the force begin. And if I pause here, so I move on this diagonal, and we have a force on the same direction. Oops. And if I move in this direction, and I can move in this direction as well. In my opinion, most of the time it's looks a little bit more wonky and more strange, because here you could see it's doing something strange with particles. Most of the time I don't like this effect, but maybe for your purposes the optical flow will work for you better than the slope. Me, on the other hand, prefer the slope for such approach. Alright. What else? The else is feedback. And this one would be a little bit stranger. Oops, I turn off this component. Let me, from the render, I could make a feedback system, but I'll do even simpler. Then I could blur it, blur my particles. And I could do a threshold. It's a very common trick to make a blobs, oops, 0.1. Yeah, and then blur it again. And I could use this image for creating a vector field. So it would be a feedback. Our rendered particles would affect the force of a particle. And to make it, we need, because it would be a feedback loop, it would be the recursive problem. I forget how it's called. Okay, let's call it the problem of recursion. So we need to set it with feedback. Here's our feedback. And composite over 1, maybe under, sorry. Let me find something good. Let me check actually what I already did here, because I find a nice setup. Below threshold. Oh, I could use it like that. Okay. It's even simpler. Alright. I don't need it here. Let's make it null. And here let's make a select. I use the select only because I don't like to connect it like this because it looks ugly. So I prefer on this distance to use the select, but it's the same as varying. And let me check it again. Something. Okay. Sorry about this. It's, yeah, when I'm talking English and connecting everything, sometimes I think not as good as normally do. So, copy parameter, the constant, paste expression, feedback, delete this. I don't need anything here. And to reference feedback, I could reference it here. So now we have our rendered and a little bit blurred particles, and we could use the same slope. Also in the slope I recommend to use to check different methods. Sometimes one works better than the other. And now we have the strange vector fields. Let's first look how it watch how it looks. Let me turn off. Yeah, sorry. The strange thing about such kind of feedback loop, somehow it doesn't work really well with these arrows. So you need to turn off the arrows. I'm not sure why it's going on. Float. Not sure why it works this way, but instead of looking on the arrows, let me show it what's going on here. Now the particles from here affects our vector field, and so it would be a feedback system, and the path where particle goes affects how it moves the next one. So it's kind of a little bit resembling the cellular automata or the Fusarium system, and by changing different parameters and changing different parameters here, and it actually looks much nicer if we make a resolution a little bit bigger and the scaling a little bit smaller. So it looks like a sand or something, and you could clearly see that there is some kind of feedback system is going on. And this is just as simple the blur threshold. Actually, I even turn on the threshold here. But of course you could use some kind of crazy feedback system with trails, with level going down, and so on and so on. So it's really interesting to experiment with this technique, and also experiment with a different strength, because if I turn on in different direction, it becomes some kind of radial too. So please experiment with this technique, and if you found something interesting result with feedback, please share in the comment section or on my Patreon or somewhere else. I really would like to see what else you could do with this approach. I haven't seen it before actually, so I don't know, maybe I invented it, but I'm not sure. Probably someone before me also have this idea. But that's interesting, at least for me. Okay, this is our trick with the force, and let's move on. Let's move on to the angle trick. We almost go to the end now. So let's make something less crazy. Something less crazy. Okay, we have a lot of particles. We have, I don't want mouse. I would actually prefer this one. Setup. Okay, this looks nice. What else you could do is you could use the quantizing. It's on the level, oh sorry, it's on the limit, on the quantize tab, and if you quantize for the round and set it, for example, 0.25, and maybe set it before limit, quantize round 0.25, and how to show it to you. Let's make a math a little bit smaller. A velocity, I mean, let's make velocity a little bit smaller, and maybe even turn on everything and leave only the noise. And if I set the limit to the 0.5, probably you will see what's going on. No? 0.25. Oops, sorry again. Something wrong here. 50, let's make scale into 2. Ah, okay, I got it. As you could see now with the limit, we limit in our, and let me turn off this noise. If using the quantized values, we could manipulate the angle of the movement. Right now it's look a little bit clumsy. Limit time, 0.25. Okay, now it's better. So as you could see, now we before that we have a lot of different angles. Maybe it would be a little bit easier to see if I increase the period of the noise. So here we have a smooth angles, a lot of directions, but if we quantize it, we have just straight angles like here, and our particles start moving on the lines, on the straight lines. And it's important here on the GLSL, on GLSL multi in our particle system, you need to select the nearest pixel, because if we interpolate, it makes it a little bit smoother, and so it's less visible. Now you could see like particles moves almost smooth, but actually it's not, because you could see the arrows. But if you set the nearest pixel, the particles also move in the lines. And maybe you would like this effect. Especially it's very good for making the static images, but even in the dynamic, like here, it also looks nice, at least in my opinion. And let's turn on. If I turn on noise, it becomes again a little bit more not so straight. So, and maybe the math to 4. But you should be careful, because for example, if I set the value very high, because here on the noise most of our position is near the 0 somewhere. As you could see, it's something 0.1, 0.0 something. So when you quantize it, it becomes just 0. So that's why the particle just stops here. Also, it depends on where you put it. If I put it here, it would be a little bit different. It will look a little bit different. So, experiment with the limit. It creates a little bit different movements, as you could see, 0.5. And also you could experiment with the quantized position. It will create kind of cellular pattern. For example, here we have 4x4 grid. If we move our offset, no. So I could turn off this grid, and yeah, 0.5 maybe. And now we have, and I could turn off this. Maybe again increase the number of particles. And a totally different look right now. So experiment with the angle streak. It will create a differently particle system with different force. Here how it looks. Actually probably it's even easier to understand by looking here. It's an input picture, it's the output. So in every of these squares, the forces goes in the same directions. And that's why it creates some kind of grid. And probably it will work good with the noise. Maybe a tiny bit of noise. Maybe even less. But again, yeah, you could experiment with the values and stuff a long time to achieve the perfect image, but we don't have the time for achieving the good looking, so please experiment by yourself. And I could turn on both of this. And yeah, some kind of crazy particle system. And you could, for example, use one limit before and one limit after, and so on. All right. And for maybe, yeah. Here I use the simple feedback system with feedback and level with opacity, and it looks, maybe it's easier to understand what's going on here because I leave the particle trace and you could clearly see the angles. And if I set on the limit here, if I set, for example, from 0.25, we have different angles. 0.5 the even different. And let me also show on this example how this, here on the nearest pixel we have very straight angles, and if I set it to interpolate, it's also, you could see this kind of angles. And let me, you could also see these angles, but it's a little bit rounded angles. So yeah, this quantizing position works really well if you use the feedback of the particles, rather than what I did it with here without. But yeah, maybe this also looks good to you. So experiment with this. And the last one is a scale field, or actually and a lot of different kind of fields. Let me turn this off and let me mix a little bit back, because on the bigger particles it's easier to see everything what's going on. And let me back to interpolation. Okay, we're back to our particles, particle movements, everything is fine. And here we use our particles, we use these vector fields for creating vectors. So the direction and the speed of our particles. But what if you use the same approach for affecting something else? For example, for affecting scale, or for affecting rotation, or color, or age. And it's totally possible to do. So, what do I mean by that? I mean that you could create again, we need here for the particles, for the creating vector fields, we need the feedback position or or feedback scale, in our case, default scale, and the velocity, the changing of a scale. And what I want is, for example, let's make a rectangle. And let's rotate to 45. 1, 1. And move it here. Yeah, something like that, for example. What I want is to create a field when the particles appears in this area, it will increase in the size a little by little. And if it in this area, it will decrease the size. So it's like a flow field, but not for the velocity, but for the size of a particle. So, and also I want to show you that here I'm using 3 inputs because I need X and Y position. But if I want to scale the particles uniformly in X and Y, I actually can put everything in one top because I need the feedback. I call it feedback scale. Feedback scale. This would be a scale field, or actually, oops, let's make a null to change it later. Scale field, and we also need the default scale. And for the default scale, let's use the scale, I don't know, let's use the constant. Default scale. Alright. And we could combine it in one top because we only need 3 channels. Because, yeah. And let's make everything 32 bits float. And let's use the reorder top. And like here, there we store on the first channel. So input 1, output red would be input 1 red. Second, it's our default. So second is our default. And the third is our field. Input 2 red, input 3 red, and alpha to 1. Okay, and let's call it scale field. Because yeah, sure. And let's connect it to the GLSL. And here we could output 2 buffers actually. And here by default it was set to 1. If I set it to the 2, I could use the render select and use the color buffer index 1 here. But right now I don't have the color buffer. It would be called, I want to output scale here, our feedback scale. Okay, let me edit a file. And on location 1, I want to output out scale. And here I want to out scale vector for scale. What we also need is the scale multiplication. And now we have this on input 3. So let's call it scales, and it's input 3, and we need actually R, G and B channels only. So let's now create our variables. Our scale is the red channel because it's go from the feedback. It says scales are and the scales field here is our, we add to our scale we add the blue channel because we store the field on the blue channel. As you could see on the output blue is this one. Blue channel multiplied by Y and X. So basically I create the very same code as here, and we need to make a default scale equals scales green, and default scale is scales green. All right, and maybe we'll set default to 0, but let's see. So it should work, and we need to add new variable here on the vectors page. We use scaled multiplication. We use this expression. It's actually 1 divided by FPS, so 1 divided by 60 gives the same number, but you could use this handy expression. And I usually like to use some kind of random numbers like 99999 to make me a visual cue that these values wouldn't use. So in every of my parameters I use only 2 parameters. It's just easier to see. Okay, so if I save, I have the problems in string number 19 vectors. Yeah, because it's vector free. Sure, it's vector 4, so it's not RGB, it's RGBA, and therefore output I could output just scales. It should work, right? And let me see. Yeah, but actually I would actually like to output only this scale. And let's check how it works, if it works. Have this scale. Okay. The feedback always needs some kind of input, even 0 input. So, but now our scale should be, our rendering scale should be not the age, but this our scale. And let me see if everything's going on right. I could easily check it with multiply it by 0, so I have now vector fields, particles don't move. Let's turn on noise. And as you could see, the particles over here, over these triangles, it start growing. It's also growing over here, by some reasons. Why it's growing over here. And let's make a constant scale just to turn off noise. Yeah, now it looks good. As you can see over here, particles grows, because when the particles is on this area, it starts increasing in scale, and in this area it decreases in scale. But because we have our limits, or what? Oops, let me turn on. Yeah, it grows in scale. 1, 1, 1, 1, 1, 1, 1. Yeah, it goes bigger. And over here, our scale equals to 1. Why it equals to 1? Because it equals to 1, because here is 0. Of course, here is 0. And we need the background color to not to 0, but to -1, -1, y -1. And we could easily make it with the math. Let's make it math. We have from 0 to 1, and we want it from -1 to 1. And now you could see we have a little bit of bug, because when the scale is negative, and it's clearly negative here, it's super negative. If I pause, it's -20 something. And the rendering system doesn't know what to do when our scale is negative, how to render it. And probably it renders like it's positive. So we need to limit our scale from 0 to 1, or something else. Let's see, let's put the limit, and let's put the clamp, and the minimum value 0.1. So let's make it not disappear completely, and the maximum, let's call it 5. And we want this to feedback. Yeah, now it works fine. It starts growing, it's grow only until it reaches number 5, and it goes, the minimal is 0.1. And now let's test it with the moving particles. Let's move the particles. Yeah, let's move the particles. And now, as you could see, maybe we would like to limit it a little bit more, like 25. Yeah. Maybe my minimal particle would be 1. And we add a noise, so it's not clumping together. And all right, so that's it for the scale. Why it stops over here? It stops over here because when particle reach the value of a 0, because we still have this aging effect, and the aging effect, yeah. Sorry, let me pause because I lost my thought. So okay, it took a little bit longer than I thought, and the problem was here in the limit, because it's limiting from 0 to 1, and it's limiting the alpha channel as well. So that's why if I don't turn off the alpha channel, it goes, and eventually it will die and stop, because now the alpha is 0. And if I turn off the channel mask, turn on channel mask for alpha, everything goes fine. Okay. Oof. And also I checked how much time I already spent on this tutorial, and probably nobody of you have watched and listened so far, because it's 1 hour and a half. So let's go towards the finish now. Okay, of course you could use here, instead of this boring rectangle, you could use some kind of noise and copy parameter, past expressions, 0, 1, oops, 0.5, okay, 0, 1. If here we have 16-bit floats, then we don't need math. And maybe make it a little bit bigger, like period of 3 and 1 harmonic. And now we have the same effect, but a little bit less predictable as here. But you still could see it probably. And you could use the same approach, not for the scale, but for example for rotation, for the color, or for something else. So the vector field, the flow field shouldn't be always for the vectors, for the velocity, but it could also be for something else. Alright, and let me switch back it to, or maybe I could try, maybe actually I could, okay, we don't have time for that, let's leave it in this one. And yeah, and now it's a very messy network, but if you follow me, probably it's less messy for you, maybe it's not, I don't know. And the last I want to show you, and I wouldn't explain it in much detail because it's almost nothing to explain. Here the same thing going on. The only difference is that here I create the feedback system and I want to stop somewhere. So for example here when everything is dies and everything stops, the particles didn't reappear again. It didn't reappear again because here you could see, instead of using the voltage after particle dies, the age equals to 0. So the particle dies and that's it for the particles. And in the end it generates the vector field or flow field as a single image. And here it's also you could experiment with interpolation with the nearest pixel, or you could start from the nearest pixel and somewhere in the middle of the way switch to interpolation, and so we have straight lines and not straight lines, and experiment with palette and everything, so on. And also in this setup I used a lot of tricks we talked earlier, and some other tricks, like here instead of a simple circle I used with a noise and I add a little bit of rotation, so with different angles. But overall it's the same only for the static images, not for the video. And if you want to know more about static approach, I recommend you to read the Flow Fields article by Tyler Hobbs. It's very famous generative artist and very nice and useful website, and I really recommend you to read all of his articles. But this one is about our topic. And here is a pseudocode. So hopefully you could read this pseudocode and try to recreate it in GLSL or in TouchDesigner or in any other language you choose. So that was a very long tutorial after the long break, and I hope you like it, and please subscribe, and if you want you could support me on the Patreon. And oh, I forgot about this one. Okay, super fast. Here is just my test between fragments of shaders and compute shaders, because if you're not on a Mac, if you're on a PC, you could use compute shaders. and I just thought the compute shaders would be much faster, but hey, the compute shaders, it's a yellow one, and it's actually a little bit slower. So maybe this vector field, it's not the appropriate task for using the compute shaders. But if you're interested, and I have this component on my Patreon, you could just read and understand to better understand difference between the syntaxes of a compute shader and the pixel or a fragment shader. And the code is the same, and it's the same as in our starting point, but a little bit different syntaxes, but not so much. But anyway, if you're a Mac user, you could stick with the fragment shader because it's only you have, and it's still very actually it's a better computational time than a compute shader, so it's not worth to switch into the compute. Okay, and now for sure that's it, and see you next time. Bye bye.